Okay, the question says that the volume of CO2 obtained on complete decomposition of ethane gram of barium carbonate at STP. So we basically have to determine the volume of carbon dioxide produced. Now the chemical reaction of decomposition of barium carbonate will be, that is barium carbonate upon heating will produce barium oxide plus CO2, just similar to limestone. So this will produce CO2. Now we have to find out the volume of CO2 that can be obtained when this barium carbonate, that is 19.73 gram of barium carbonate, is heated or decomposed at STP. So we'll first go for the mass, that is we'll find mass first, and after finding mass of CO2 obtained, we can find out the moles of CO2, and after the moles of CO2 being find out, we can go for the volume of CO2, right? So the from this we know that the carbon dioxide has gram molecular mass of 44 gram, and this barium carbonate, since atomic masses are given, so the barium carbonate, the gram molecular mass of barium carbonate comes out to be 197.3. Right? Now we can say, from this we can say that 197.3 gram of barium carbonate will produce 44 gram of carbon dioxide, right? So I'll write down 197.3 gram of barium carbonate will produce 44 gram of carbon dioxide. So this will produce 44 gram of carbon dioxide. Okay, then 1 gram will produce, obviously 1 gram will produce 44 upon 197.3, which comes out to be 0.22. So this much gram of carbon dioxide will be produced from 1 gram. Now in the question it is given that 19.73 gram of barium carbonate is decomposed. So if 1 gram produces 0.22, that means 19.73 gram will produce 0.22 multiply by 19.73. If 1 gram produces this much, then 19.73 will produce 19.73 multiply by 0.22. Now this value comes out to be, on dividing this we'll get 4.4. So this 4.4 is actually the mass. So this 4.4 is the mass of CO2 obtained. Now from this 4.4 we can find out the moles. From this 4.4, let's say, let me turn this page. So from this 4.4 we can find out the mass. Now since 4.4 gram of CO2 is formed, so that means number of moles of CO2 will be 4.4, which is the mass we obtained, upon molar mass of CO2, which is 44. So upon dividing this we get 0.1. So that means 0.1 mole of CO2 will be formed. Now we also know that 1 mole of any gas at STP, either CO2 or something else, since CO2 is mentioned, so we'll say 1 mole of CO2 at STP will occupy 22.4 liter volume, right? 1 mole of any gas at STP will have 22.4 liters. Now the mole of NO2 we obtained is 0.1. If 1 mole has a volume equal to 22.4 liter, that means 0.1 mole will occupy a volume equal to 22.4 multiply by 0.1, right? Multiply by 0.1. This value comes out to be 2.24 liter. So this is the answer, that is 2.24 liter.